Okay, this is going to be the solutions to a couple of other homework problems that use a graph where we don't have an algebraic equation. And as I said in class, the main thing here to remember is that when you have the graph of a function, f of x means the y-coordinate on the graph. So in this picture, for example, if let's just say, for example, that I want to identify h of -2, just as an example, then this number I'm putting in is the x-coordinate that I'm telling you, and the answer is going to be the y-coordinate. And so if I look on my graph, when x is -2, the y-coordinate on the graph is 0. So from the graph, I can see that h of -2 is equal to 0. So I can evaluate a function from its x-coordinate and from its graph without having an algebraic formula. So having said that, in this picture, if I want to see what's going to happen as x approaches 0 from the right, that means that I'm looking at x-coordinates that are getting close to 0. Let me just highlight over here. I'm looking at x-coordinates getting close to 0, but being bigger than 0. So I'm looking at x-coordinates in this region. Okay, so getting close to 0. X-coordinate of 0 would be right along the axis, right? So the x-coordinate of 0 is right on the axis. So think about what's going to happen as my x-coordinates get close to 0 from the right. Imagine that you're walking along this curve and you want to know, as your x-coordinates are getting close to 0, what are your y-coordinates getting close to? And the answer is that as the x-coordinates getting close to 0, you're getting closer and closer to this point right here. And the point right here has the y-coordinate of 1. So as the x-coordinates get close to 0 from the right, the y-coordinates get close to 1. And so I would say the limit as x approaches 0 from the right of h of x, remember h of x stands for the y-coordinate on the graph, will be 1. And then similarly, if I'm coming into my x's are getting close to 0 from the left, over on this side, now imagine yourself walking along the graph with your x-coordinates getting close to 0, but staying to the left of 0. Now, as you get close to 0, your y's are getting close to the y-coordinate of this point, which has a y-coordinate of 2. So, as x gets close to 0 from the left, the y-coordinates are getting close to 2. Since these are not equal, the y-coordinates are not equal coming from the left and from the right. That's why we would say that the limit does not exist. If I asked you on this picture, if you were walking along the graph and your x's got close to 0, what does your y-coordinate get close to? Your answer would be, it depends on whether you're approaching 0 from the left or you're approaching 0 from the right. You're not going to end up with the same y-coordinate from both directions. And so when the answer is, it depends on which direction you're coming from, we say the limit does not exist. Now, on the other side, this one has a graph that's not defined in two pieces, but we can do the same thing. Here we're looking at the limit as x approaches -4. So as we approach -4, let's first of all think about it from the right. Again, imagine that you're walking along the curve so that your x-coordinates are getting closer and closer to -4. Right, -4 is here. So if I'm walking along the curve where my x-coordinates are getting close to -4, you can see that my y-coordinates, the closer I get to -4, the closer my y-coordinates get to 4. Right? The closer your x's get to -4, the closer the y-coordinate gets to 4. And so I would say the y-coordinates here are getting close to 4. And unlike the previous problem, if I approach -4 from the left side, my y-coordinates are also getting close to 4. So now these are equal, and so I can just say that the limit as x approaches -4 of f of x is equal to 4. Because these agree, that's my answer to the limit question. In the previous problem, those didn't agree, and so I would say that the limit does not exist.